In stage 1, we saw conversion. The first problem, a truck carries 250 bolts of cement. If each bolt has 50 kilograms, what is its equivalent in tons? So we know that a ton is 1,000 kilograms. So let's first we're gonna have to know how many kilograms are in the 250 bolts. So multiplying this, we get this in this the total of kilograms we have in the 350 volts. So now we're gonna convert it into tons. We have 17,500, and we know that a ton equal to 1,000 kilograms. So what we're gonna do is divide this in this, because this gets cancelled, and it's totally totally 17.5 tons. The other topic that we saw in stage 1 was conversion with potential. So let's read. A prism is 10 centimeters each side and its height is 80 centimeters. Determine the prism volume in centimeters cubic and meters cubic. So that's the problem. Black marker, please. So let's draw the cube. So we know that the base is 10 by 10 and the height is 8. So we're going to multiply each other. And it gives you a total of 8,000 centimeters squared. So we already got the centimeters squared. Now we're going to convert it to meters. We know that. Blue marker, please. We know that a centimeter cube is the same to 100 meter cube. So we're gonna divide 8,000. This gives us 8 meter cube. And that's our result.
If a displacement of 45 meters north is added another one of 60 meters to south, what would the resultant vector be? Black marker, please. Thank you. These kind of problems are very easy. What we have to do is just first draw a graphic. You need to, and here it says we have a displacement of 45 meters to north, and then it's another one 60 meters to south. What we only have to do is just make a subtraction. Yes. Minus 45. That's it.
Hello, I'm going to do stage number 2, additional vectors. Okay, here we have the problem. A child pulls a little car using a force of 70 newtons, right? Which forms an angle of 30 degrees with the horizontal force. Determine the magnitude of the horizontal force using to pull the car and the vertical magnitude that is applied on it. Black marker, please. Thank you. So here is asking us two things. The magnitude of the horizontal force and the vertical magnitude that is applied on it. So it asks us the horizontal and the vertical, right? So for this example, here we have the representation, the graphical representation is a little car. It's 7 newtons and it's at a degree of 30 degrees, right? So for this example, we need to get the Vx and the Vy, which are the components of the angle, which are these. Vx is the representation of the x, which is the horizontal force, and Vy is the representation of the component y. So here the formula for using Vx is cosine of the angle and the magnitude, or the newtons, and for Vy is sine of the angle in the newtons. So for Vx we have, for this we need to use a calculator. Cosine of the angle, which is 30 degrees cosine, that gives us 8.66, right? And then this is the newtons. So Vx equals that times the magnitude used of the force, 70, and that gives us an answer of 60.62 newtons. Always remember to use newtons. So this is the first answer. Vx is the horizontal force. So horizontal force, done. Now vertical force. Vy equals sine of the degree times the newtons. Vy equals 30 sine, which is 0.5, times the 70, which gives us an answer of Vy equals 35 newtons. So that's how you do a problem like this.
The first problem is about ULM. The problem says, in a baseball park, the distance from the pitcher's mound to home plate is 18.5 meters. If a pitcher can throw a ball at 40 meters per second, and considering this speed is constant, this is special information, how long does the ball take to reach the plate? The first thing we need to do is to know the formula of ULM. The formula of ULM is equal to distance equals to velocity times time. Knowing this, we know that 18.5, because it's meters and it's the distance, it's equal to 40 meters per second times time. We need to isolate time in order to get it. We pass the 40, that is multiplying time, to divide it, and it gets the following division, and the answer is 4.4625 seconds. Well, the first problem of the next topic is uniform acceleration motion, and we have the formulae that are 5 formulas, and the problem says the technical manual of a Golf GTR car of last generation established that it can accelerate from 0 to 100 kilometers per hour in 6.2 seconds. the first question says, what is the acceleration? We have that data is initial velocity equal to 0, final velocity it's equal to 100 kilometers per hour, and then we have to convert 100 kilometers to meters per second. And this is equal to 27.7 meters per second. The time is 6.2 seconds. Now that we have the final velocity in meters per second, we just have to use the first formula. It's 27.7 minus 0, acceleration, divided by time, which is 6.2. Then we have the acceleration, it's equal to 4.46 meters per second squared. The second question says, what is the distance traveled? The data, the past problem is 6.2 seconds. Our acceleration is 4.46 meters per second square. The final velocity is 37 meters per second. Now we have to use another formula, and that formula is the following. The formula says distance is equal to initial velocity, which is 0 plus final velocity, 37.7 divided by 2 times 6.2 seconds. And then we have the distance. And the result of the problem is 85.87 meters. The problem says a fuel drop body reaches the ground with a velocity of 29.4 meters per second. Determine the fall time. The data that we have is final velocity, which is 29.4, and the acceleration, that is the gravity, of 9.8 meters second square. Having this, we need to find the time using the third formula, and it's equal to final velocity equals 9.8 gravity times time. Isolating the t, we have the result. The time that we have is 3 seconds. The other question of this kind of problem is the height from which it was dropped. Now we have another data. The same, 29.4 meters per second. But now we have 3 seconds, and the acceleration that is 9.8. And we need to find the height, which will be represented by y. We will use this formula. The formula is height is equal to gravity times time squared divided by 2. The height is known, the gravity is 9.8, time squared, which will be 9, which is 3 squared, and divided by 2. This is equal to y, equal to 88.2 divided by 2. And finally, A is equal to 44.1 meters. Thank you.
Two different exercises of the stage number 4, and the topic of this exercise is horizontal throw, and it's made by me. And the exercise says a projectile is fired so that its initial vertical component is 27 meters per second and its initial horizontal component is 34 meters per second. Find the initial velocity of the projectile, magnitude and direction, the time, and the horizontal distance traveled. In this exercise, we are going to this is the data. By is 2.7, bx 43, b 43.4, and the angle is 38.5. And this is going to be the formula we are going to use. R is equal to b squared sine of the angle for 2 over gravity, and this is going to be R is equal to 43.4 raised to the second power, and the sine of the angle multiplied by 2, the angle is 38.5 over the gravity, that is 9.8. And this is equal to 43.5. And the values from the letter x are bx is equal to 15 meters per second, x equals 47 meters, and the time is 3.19 seconds. And the values for the letter y are equal to 50, and the gravity is 9.8, that's normal, and the final velocity is 31.29. And this is the formula we are going to use to make this problem, and we are going to the gravity is 9.8, the time is raised to the second power, so it's time 3.19 raised to the second power, and all of this is divided by 2, and this is equal to 247. Meters. And for the letter A, we are going to get time. So we isolate the letter T, we pass it to the other side. So the gravity is 9.8, the time, the letter y is equal to 50, and all of this is divided by 2.